In the deepest reaches of our solar system, cloaked in eternal night, drifts a small frozen world forgotten by many, underestimated by all. But hidden beneath its icy crust, shielded from cosmic radiation, could lie a secret that changes everything we know about life in the universe. Pluto, once thought dead and silent, may harbor a hidden ocean, a chemical heartbeat, and the essential ingredients for life. Tonight, we journey to the edge of the sun's reach, to a place where life might exist against all odds. Far beyond the orbit of Neptune, where the sun is nothing more than a dim, cold star, a small world drifts through an endless sea of darkness. Pluto, once hailed as the 9th planet of our solar system, then demoted to a mere dwarf planet. Pluto has always existed at the edges, not just of our solar system, but of our understanding. A world both isolated and alluring. Pluto challenges what it means to be a planet, to be alive, to matter. At an average distance of 5.9 billion kilometers from the sun, sunlight on Pluto is 1,000 times weaker than on Earth. A sunny day on Pluto would seem no brighter than the deep twilight after sunset here. Temperatures plunge to an unimaginable minus 229 degrees Celsius, cold enough to freeze nitrogen solid. And yet, against every expectation, Pluto is not a dead rock drifting through the void. It is a dynamic world with flowing glaciers, towering ice mountains, active geology, a living atmosphere, and perhaps most remarkably of all, a hidden ocean beneath its frozen shell. The very existence of these features rewrote what we thought we knew about small worlds. Before New Horizons, most scientists expected Pluto to be nothing more than a battered ball of ice, geologically inert for billions of years. After all, how could a body so small, so cold, and so distant retain any internal heat? How could it have an atmosphere or surface activity or anything resembling a heartbeat? But the reality was far stranger and far more beautiful. The landscape revealed by New Horizons showed diverse terrains, some ancient and cratered, others surprisingly young and smooth. Towering mountains of water, ice soaring 3 to 4 kilometers high rise from the surface like frozen monuments. Vast glaciers of nitrogen and carbon monoxide slowly crawl across plains of frost, reshaping the surface over eons. There are hints of tectonic activity, of vast fractures tearing across the crust, and even regions that seem to suggest volcanic forces, once or perhaps still at work beneath the surface. Even more astonishing is the growing body of evidence suggesting that deep beneath its outer shell of ice, Pluto may harbor a subsurface ocean of liquid water kept from freezing by residual heat from radioactive decay within its rocky core. If true, it would make Pluto not just a frozen relic, but a dynamic world. A world where the conditions for life might persist even now in the cold shadows far from the sun. This possibility redefines what we consider habitable. It challenges the idea that life requires warmth from a star or a surface bathed in sunlight. Instead, Pluto hints at a universe where life might thrive in darkness, warmed only by the faint glow of internal heat shielded beneath layers of protective ice. In many ways, Pluto stands as a monument to resilience. Tiny isolated and battered by the harshest environment imaginable. It nevertheless endures. It evolves. It breathes. Pluto's very existence forces us to rethink the boundaries of our search for life, not just among the bright stars, but in the hidden oceans of icy moons and dwarf planets across the cosmos. And beyond its scientific significance, Pluto stirs something deeper within us, a recognition that even the smallest, most distant places matter. That even in the coldest, loneliest corners of the universe, there may be movement, mystery, and meaning. To study. Pluto is to study perseverance itself. It is to understand that life in all its stubborn beauty might not be an accident of warmth and sunlight, but a universal force ready to bloom wherever conditions allow. Even in the eternal night at the edge of the sun. Tonight, we begin a journey into that mystery. A journey across frozen plains, beneath hazy sky, into oceans we cannot see. A journey not just to Pluto, but to a deeper understanding of what it means to live, to adapt, to endure. And it all starts here, at a frozen world. For centuries, humanity gained into the heavens, mapping stars, charting planets, and gradually uncovering the grand architecture of our solar system. By the late 1800s, we had identified 8 planets orbiting the sun in elegant order. But even then, something didn't quite add up. Tiny irregularities in the orbit of Neptune puzzled astronomers. They noticed that the giant blue planet wasn't moving precisely as expected, hinting that another more distant body, yet unseen, might be exerting its gravitational pull. This hypothetical world was called Planet X, and it haunted the calculations of one man in particular, Percival Lowell. Lowell, a wealthy and passionate astronomer, had already earned fame and ridicule for his controversial theories about canals on Mars. But Planet X was his true obsession. In the early 1900s, he poured his resources into building the Lowell Observatory in Flagstaff, Arizona, where he led a search for this invisible planet, using complex mathematical predictions to estimate where it might be found. He died in 1916, without success. His legacy, however, endured. The observatory continued his work, and over a decade later, a young self-taught farm boy from Kansas named Clyde Tombaugh was hired to carry on the search. Tombaugh had no formal degree, but he had something far rarer: patience, discipline, and vision. He began work in 1929. Assigned to operate a 13-inch astrograph telescope and photograph the night sky. His job was as tedious as it was monumental. Take multiple exposures of the same section of the sky, days apart, then use a device called a blink comparator to compare the images flicking back and forth to detect any movement against the background stars. For months, he worked in silence, scanning thousands of tiny white dots. Most never moved. But on February 18, 1930, he noticed something. A speck of light had shifted. It wasn't a star. It wasn't a comet. It was something new. He had found Pluto. News of the discovery spread rapidly. For the first time, an American observatory had discovered a planet. The world erupted in celebration. Naming the new world fell to the public, and it was an 11-year-old girl from Oxford, Venetia Burney, who suggested the name Pluto after the Roman god of the underworld guardian of hidden things. It was perfect, a world shrouded in shadow, only now brought to light. Astronomers welcomed Pluto as the 9th planet of the solar system. But from the very beginning, it was a strange fit. It was small, smaller than Mercury. Its orbit was highly elliptical and tilted, unlike the neat flat orbits of the other planets. And even its brightness was odd, fluctuating mysteriously. Still, the discovery was a triumph. It fulfilled Lowell's dream, honored Tombaugh's meticulous work, and captivated a world hungry for mystery. But beneath the celebration, a subtle problem lingered. Lowell had predicted that Planet X would be massive, many times larger than Earth, to account for the irregularities in Neptune's orbit. Yet Pluto, as later measurements would show, was smaller than Earth's moon, and its mass too slight to have any effect on Neptune at all. The supposed wobble that had driven the search, likely an observational error. In an ironic twist, the discovery of Pluto had nothing to do with what prompted it. And yet that didn't diminish its significance. Because sometimes science advances not by confirming what we expect, but by revealing what we didn't even know to look for. For over 75 years, Pluto held its title as a planet taught in classrooms, listed in textbooks, and loved by generations. It became part of the mythology of space exploration, symbolizing the frontier, the edge, the final outpost of the known system. But in time, as telescopes grew more powerful and technology more precise, Pluto's position would once again be questioned. Even so, its discovery remains one of the great stories of astronomy. Not because it answered a question, but because it reminded us that even the vast emptiness of space can still hold surprises, that a humble observer with a steady hand and a clear eye can change the way we see the universe, and that sometimes For decades after its discovery, Pluto remained a mystery, cloaked in light and distance. Even the most powerful Earth-based telescopes could only capture it as a faint, flickering point, never more than a shimmering speck moving slowly across a field of stars. From that single dot of light, astronomers struggled to estimate its size, its mass, even its surface. The truth was hidden by distance, guesswork, and our own assumptions. At first, Pluto was thought to be enormous, perhaps as big as Earth. After all, how else could it explain the mysterious movements of Neptune? But as decades passed, and as technology advanced, that illusion faded. The arrival of Charon, Pluto's largest moon, discovered in 1978, changed everything. By watching how Pluto and Charon orbited each other, scientists could finally measure their masses more precisely, and the result was shocking. Pluto was tiny, just 70 kilometers in diameter. That's about 2/3 the width of our moon, and far smaller than even Mercury. Its mass, merely 0.2% that of Earth, a cosmic pebble. Even its orbit defied planetary norms. Pluto's path around the Sun is not a near-perfect circle, like most planets, but an elongated oval. Sometimes it even swings closer to the Sun than Neptune, as it did from 1979 to 1999. Its orbit is also tilted 17 degrees off the ecliptic, the flat plane in which all other major planets lie. In every way, Pluto was the solar system's oddball. For much of the late 20th century, that's all. Pluto was a strange, icy rock in the distance, its features imagined but unseen. Then came July 14th, 2015. After a journey of nearly a decade through deep space, NASA's New Horizons spacecraft performed the first ever flyby of Pluto, passing within just 500 kilometers of its surface. In the hours that followed, the spacecraft began transmitting images back to Earth. What we saw shattered expectations. Pluto was not a featureless snowball. It was breathtaking. Its surface was a canvas of complexity: mountains, valleys, plains, ridges, and craters. It had color, soft reds and browns and grays. It had weathered terrains. It had geological history. It had stories. Towering ice mountains, some more than 3,500 meters high, rose majestically from the surface. These were made not of rock, but of water. Ice frozen so solid by the frigid temperatures that it behaved like stone. Adjacent to the mountains lay a massive heart-shaped plain of frozen nitrogen, smooth and almost entirely devoid of craters. This was not an ancient, lifeless world. Parts of Pluto's surface were geologically young, maybe less than 10 million years old. To put that in perspective, Pluto formed over 5 billion years ago. Yet something even now is still shaping its surface. This was the first shock. The second, there were no signs of planetary rings, no thick atmosphere, and no magnetic field as we know it. But what Pluto lacked in grandeur, it made up for in mystery. Its surface was divided into distinct geological zones, some filled with impact craters, indicating great age, others oddly smooth and new. There were dark, equatorial bands that hinted at complex chemistry, possibly created when solar radiation struck Pluto's methane-rich atmosphere, forming complex organic compounds called tholins, substances also found on Saturn's moon, Titan, and in comets. These tholins settled onto Pluto's surface like cosmic soot, giving it a burnt reddish tint and painting its equator with long, dark scars. There were also signs of glacial flow evidence that Pluto's ices move, slide, and interact with terrain just as glaciers do on Earth. These movements suggest Pluto's surface is not static, but dynamically active, reshaped over time by processes driven by internal energy. But where does that energy come from? Pluto is too small to generate tidal heating like Jupiter's moon. Europa, it's too far from the sun to receive much solar warmth. The best explanation is that Pluto retains some internal heat, likely from the decay of radioactive elements in its rocky core. It's a slow process, but over billions of years, even a trickle of energy can keep ice moving, reshaping, evolving. And perhaps beneath it all, a vast hidden ocean of liquid water endures. This ocean, if confirmed, would be one of the most significant discoveries in planetary science. It would mean that even the smallest, coldest, most distant worlds might still hold the key ingredients for life. And yet Pluto doesn't brag. It doesn't rage with storms like Jupiter or dazzle with rings like Saturn. Its beauty is quiet, cold, patient. Pluto is a world that whispers, not shouts. But those whispers carry deep truths about the resilience of ice, the subtle power of chemistry, and the boundless possibility of life beyond the warmth of the sun. It reminds us that the universe is not just about scale or brightness. Sometimes the most profound wonders hide in the places we almost forgot to look. And in Pluto, we didn't just find a planet or a dwarf planet. We found a mystery. Imagine standing on the frozen surface of Pluto. The sky above is black, pierced only by distant stars. The sun, a pale pinprick of light, offers no warmth. Around you, the silence is total. You are alone in the coldest place you've ever known. And yet, something stirs. For reasons still not fully understood, Pluto has an atmosphere, a thin, ethereal veil that clings to its icy shell like a ghost. This atmosphere, barely there by earthly standards, is one of the most surprising and haunting features of this distant world. The very idea of an atmosphere on Pluto defies expectation. At an average distance of nearly 6 billion kilometers from the Sun, where temperatures hover around 229 degrees, all logic suggests that Pluto should be an airless rock, its gases frozen solid on the surface. And yet when New Horizons approached in 2015, it discovered that Pluto was not only breathing, it was glowing. Let's begin with its composition. Pluto's atmosphere is made up of more than 98% nitrogen, the same molecule that dominates Earth's skies. The rest is composed of small amounts of methane and carbon monoxide gases that sublimate or turn directly from solid to gas when sunlight warms the surface even slightly. This process is slow, delicate, and seasonal. When Pluto moves closer to the Sun, during its 248-year orbit, frozen nitrogen and methane begin to evaporate from the surface, forming a temporary atmosphere that can extend hundreds of kilometers above ground. But when Pluto swings back to the far reaches of its orbit, the temperature drops and the atmosphere begins to collapse, freezing back onto the surface in a silent, icy rain. At its peak, Pluto's atmospheric pressure is around 10 microbars, a mere 100,000th of Earth's sea level pressure. To a human, it's functionally a vacuum, and yet to scientists, it is a treasure trove of complexity. One of the most breathtaking discoveries made by New Horizons was the existence of haze layers, soft bluish fogs that ripple through the upper atmosphere in multiple thin bands, like delicate silk scarves suspended above the horizon. These hazes are created when sunlight interacts with methane, breaking it down and forming complex hydrocarbon particles. Over time, these particles clump together and drift downward, settling slowly onto Pluto's surface. They are known as tholins, and they may be responsible for the planet's reddish-brown coloring. Tholins are not alive, but they are prebiotic molecules that could play a role in the chemistry of life. In fact, tholins are thought to exist in the atmospheres of Titan and early Earth, linking Pluto's ancient sky to the distant origins of life itself. But the haze does more than inspire poetry. It also shapes Pluto's appearance in subtle, beautiful ways when New Horizons looked back at Pluto. After its closest approach, it captured images of a world surrounded by a soft halo of blue as sunlight scattered through the haze layers. It was a moment of quiet wonder. A frozen dwarf planet haloed like a jewel breathing in the vacuum. Yet for all its grace, Pluto's atmosphere remains unstable, fragile, and puzzling. Its escape velocity is low, just 1-2 kilometers per second, meaning gas molecules can easily drift into space. Every second, Pluto loses an estimated 500 tons of atmospheric particles to the solar wind. Over time, this should leave Pluto airless. But somehow, the atmosphere regenerates. The frozen ices on the surface continue to sublimate, replenishing what is lost. It is a delicate balance, like a candle that flickers endlessly but never quite goes out. Even more perplexing is Pluto's recent resistance to collapse. Astronomers expected the atmosphere to begin freezing out after Pluto passed its closest point to the Sun in 1989. But in 2018, telescopes on Earth still detected it stubbornly intact. Some researchers believe thermal inertia is at play, that the surface and subsurface retain enough heat to sustain atmospheric loss and gain in slow cycles that lag behind Pluto's orbit. Others suspect that internal heat or chemical processes below the surface may contribute in ways we do not yet understand. Whatever the mechanism, the result is clear. Pluto's atmosphere is not a passive feature. It breathes in a rhythm, measured not in hours or days, but in centuries. It expands and contracts with Pluto's distance from the Sun, rising like a sigh and falling like frost. And in its breath, it carries chemical complexity, seasonal change, and a hint, just a hint, of habitability. Because if Pluto can sustain an atmosphere this fragile, this beautiful, then perhaps it can sustain other things too. Perhaps it's not so far-fetched to imagine a chemistry stirring beneath its crust. A slow, icy alchemy, where pressure, heat, and time shape the ingredients of life. Not as we know it, but as it might be in the frozen frontier. In that sense, Pluto's atmosphere is not just air. It is a whisper from the dark, a quiet message that even here, on a world where no one expected motion, warmth, or breath, there is something more, something that calls us to listen closer. When New Horizons approached Pluto in July of 2015, it was expected to reveal a cold, battered world, an ancient relic scarred by billions of years of impacts and long since frozen in time. But what it found stunned the world. Dominating Pluto's surface was a massive, brilliant, heart-shaped feature, stretching over 1,000 kilometers wide, gleaming like polished ice against the dark, mottled terrain surrounding it. This feature, dubbed Tombaugh Regio in honor of Clyde. Tombaugh, Pluto's discoverer, became the most iconic symbol of the dwarf planet.